NEC Section 334.103 permits the use of Type NM, Type NMC, and Type NMS cables in Types Roman 3, Roman 4, and V construction, provided that the cables are concealed within walls, floors, or ceilings that provide a thermal barrier of material that has at least a 15-minute finish rating. ICC Section 1202.2 states that the use of Type NM, Type NMC, and Type NMS cables shall not be limited based on height, number of stories, or construction type of the building or structure. Based on these two code sections, it appears that Type NM, Type NMC, and Type NMS cables are permitted to be used in all building types, including Types I and Roman 2, provided that they are concealed in Types Roman 3, Roman 4, and V construction. However, it is important to note that local amendments or ordinances may further restrict the use of NM cable in certain types of construction. It is always best to consult with the local code enforcement agency to determine the specific requirements in your area. To elaborate further, let's break down what these construction types mean in the context of electrical installations. Understanding the building types and the associated code requirements is crucial for ensuring safe and compliant wiring practices. Firstly, let's discuss what NM, NMC, and NMS cables are. NM cable, which stands for non-metallic sheath cable, is a type of electrical wiring commonly used for residential and light commercial applications. It typically consists of two or more insulated conductors enclosed in a non-metallic sheath. NMC cable, or non-metallic sheath cable, corrosion resistant, is similar to NM cable but is designed to be more resistant to moisture and corrosion, making it suitable for damp or corrosive environments. NMS cable, or non-metallic sheath cable with an overall covering of intumescent material, is a type of cable that includes an intumescent material which expands when exposed to high heat, providing an additional layer of fire protection. Now let's delve into the building construction types as defined by the International Building Code, or IBC. These classifications are critical because they dictate the fire resistance and structural integrity requirements for buildings, which in turn influence the permissible wiring methods. Type I construction is the most fire resistant, typically used for high-rise buildings and other structures where fire safety is paramount. These buildings are constructed of non-combustible materials like concrete and steel. Type Roman 2 construction is similar to Type I, also utilizing non-combustible materials, but may have less stringent fire resistance ratings. Both Type I and Type Roman 2 construction are designed to contain fires for extended periods, protecting occupants and preventing the spread of fire to adjacent structures. Type Roman 3 construction allows for the use of combustible materials in the building's construction, but requires that the exterior walls be of non-combustible materials. This type is often used for commercial buildings and some multifamily dwellings. Type Roman 4 construction is heavy timber construction, where the structural members are made of large dimension lumber. This type provides inherent fire resistance due to the charring effect of the large timbers, which slows down combustion. Type V construction is the least fire resistant, allowing for the use of combustible materials throughout the building, including the exterior walls. This type is commonly used for single-family homes and smaller structures. The NEC, or National Electrical Code, provides specific guidelines for the use of NM, NMC, and NMS cables in these different construction types. While Section 334.3 permits the use of these cables in Types Roman 3, Roman 4, and V construction under certain conditions, it's crucial to understand the limitations and requirements. The key condition is that the cables must be concealed within walls, floors, or ceilings that provide a thermal barrier with at least a 15-minute finish rating. This requirement is intended to provide a degree of fire protection by ensuring that the cables are protected by materials that can withstand fire exposure for a short period. Now let's talk about the ICC, or International Code Council. The ICC develops a wide range of model codes, including the IBC and the International Electrical Code, or IC. Section 1202.2 of the ICC Electrical Code states that the use of Type NM, Type NMC, and Type NMS cables shall not be limited based on height, number of stories, or construction type of the building or structure. This provision appears to broaden the permitted uses of these cables compared to the NEC. However, it's important to recognize that the ICC electrical code may be adopted and amended by local jurisdictions, so its application can vary. The interplay between the NEC and the ICC electrical code can sometimes create confusion, especially when local amendments are involved. In general, the NEC provides more detailed and specific requirements for electrical installations, while the ICC electrical code focuses on broader building-related issues. When conflicts arise between the two codes, it's essential to consult with the local code enforcement agency to determine which provisions take precedence. Now, let's discuss some practical considerations for using NM, NMC, and NMS cables in different building types. Firstly, in Type I and Type II construction, the use of NM, NMC, and NMS cables is generally more restricted due to the non-combustible nature of these buildings. While the ICC electrical code may permit their use, local amendments often impose stricter limitations. For example, some jurisdictions may require the use of metal conduit or other metallic raceways for wiring in Type I and Type II buildings to maintain the fire-resistant integrity of the structure. Secondly, in Type III, Type IV, and Type V construction, the use of NM, NMC, and NMS cables is more common, but still subject to certain requirement. As mentioned earlier, the cables must be concealed within walls, floors, or ceilings that provide a thermal barrier. This typically involves installing the cables behind drywall or other fire-resistant materials. In addition, it's important to ensure that the cables are properly supported and protected from physical damage. Thirdly, when using NM, NMC, and NMS cables in any type of construction, it's essential to follow the manufacturer's instructions and all applicable code requirements. This includes using the correct size and type of cable for the intended application, properly terminating the cables at electrical boxes and devices, and ensuring that the cables are not overloaded. Overloading cables can cause them to overheat, which can lead to fires. Fourthly, special attention should be paid to the use of NM, NMC, and NMS cables in damp or wet locations. NM cable is not suitable for direct burial or for use in wet environments. NMC cable is designed to be more resistant to moisture, but it should still be protected from direct exposure to water. If wiring is required in a wet location such as a bathroom or outdoor area, it's generally recommended to use a wiring method specifically approved for wet locations such as UF cable or wiring in conduit. Let's also cover the topic of electrical boxes. Electrical boxes are used to enclose and protect electrical connections such as splices and terminations. When using NM, NMC, and NMS cables, it's important to use electrical boxes that are specifically designed for these types of cables. These boxes typically have clamps or connectors that secure the cable to the box, preventing it from being pulled out or damaged. Also be aware of box fill calculations. Box fill calculations are used to determine the maximum number of conductors and devices that can be safely installed in an electrical box. These calculations are based on the size of the box and the size of the conductors. It's essential to follow box fill calculations to prevent overcrowding the box, which can lead to overheating and other problems. Furthermore, let's also focus on grounding and bonding. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and de-energize the circuit. Bonding ensures that all metal parts of the electrical system are electrically connected, which helps to prevent electrical shock. When using NM, NMC, and NMS cables, it's important to properly ground and bond the electrical system in accordance with the NEC requirements. This typically involves connecting a grounding conductor to each electrical box and device, and bonding together all metal parts of the system, such as metal conduit and metal enclosures. Another point to consider is arc fault circuit interrupters, also known as ASICs. ASICs are circuit breakers that are designed to detect arc faults, which are a common cause of electrical fires. The NEC requires ASICs to be installed in certain circuits, such as those that serve bedrooms and living areas. When using NM, NMC, and NMS cables, it's important to ensure that the circuits are protected by size as required by the code. Surge protection is another important aspect of electrical safety. Surge protectors are devices that are designed to protect electrical equipment from voltage surges which can be caused by lightning strikes or other electrical disturbances. The NEC recommends the use of surge protection in certain applications, such as for sensitive electronic equipment. When using NM, NMC, and NMS cables, it's a good idea to consider installing surge protection to protect valuable electrical equipment. Let's also address the topic of electrical permits and inspections. In most jurisdictions, electrical work requires a permit from the local building department. The permit process ensures that the work is performed in accordance with the applicable codes and standards. After the work is completed, it is typically inspected by a qualified electrical inspector to verify that it meets the code requirements. When using NM, NMC, and NMS cables, it's important to obtain the necessary permits and inspections to ensure that the work is safe and compliant. In summary, the use of NM, NMC, and NMS cables in different building types is governed by a complex set of codes and regulations. While the NEC and the ICC electrical code provide general guidelines, local amendments and ordinances can significantly impact the permitted uses of these cables. It's always best to consult with the local code enforcement agency to determine the specific requirements in your area. By understanding the applicable codes and following best practices, you can ensure that electrical installations are safe, compliant, and reliable. This includes understanding construction types, fire ratings, box fill calculations, grounding and bonding requirements, and the use of size and surge protection. Remember, electrical work can be dangerous, and it's always best to hire a qualified electrician if you are not comfortable performing the work yourself. A qualified electrician has the knowledge, skills, and experience to perform electrical installations safely and in accordance with the code. Furthermore, continuous education on the ever-evolving code standards is an essential part of the trade. By staying updated with the latest revisions and amendments in the NEC and ICC codes, the electrician ensures all installations comply with the most recent safety regulations and best practices. This commitment to ongoing learning not only enhances safety, but also ensures the longevity and reliability of electrical systems.